This conference will now be recorded.
How's everybody doing today? Very well. That's great. We'll wait a couple of minutes, see who else joins. I think that we had a much better RSVP rate this week versus a couple of weeks ago. So we'll see how it goes. Today, as you know, we're going to be talking about DVC, direct bond copper. Hey, Greg, how you doing?
Hey, good. How are you?
Good. If you don't mind just muting your mic when we start, I'd really appreciate it.
You got it?
Thanks, man. Where are you, Minnesota or Montana?
Montana.
Loving it?
We got about 4 inches of snow last night. It's great.
I'm not jealous of that. We got Jacob, Alexander, Brian, David, Mark, Roni. All right. We'll give it another couple of minutes. How's everybody else out there? You guys can type in the chat function, the little chat box in the upper right corner if you want to say anything. You can make it public, you can make it private. All right, no takers. Gunman's joined us, that's great. I need to teach him a couple of things about DVC apparently. All right. Well, it's 3 o'clock. I guess we'll get started. Last week was really successful. We talked about just an introduction to Stellar, who we are, what we do, why we do it, and it was met with a lot of enthusiasm. And the inquiries that came from it, while not surprising, were actually more than I anticipated. So if anything we discussed today, you have any questions, comments, feedback, if you have any constructive criticism on the format in which we're doing this, lighting, pixelation of my screen, poor audio, I'd love it if you'd please send me a message or call me and let me know as we strive to make these things better each week. So today's topic is direct bond copper. And as you know, that's one of Stellar's core competencies, one of our core products. Makes up quite a bit of our business, and we've been doing it for a long time, close to 30 years. And it started out as a method for us to provide high thermal conductivity substrates to our customers, not only high thermal conductivity ceramic, but high thermal conductivity circuitry, as well as high electrical conductivity. So it was back in about 30 years ago, we were approached by a company to support their development of DVC, in which we ended up licensing the technology from GE. And what we did was, as you know, or maybe you don't know, GE discovered DVC by accident. I think they were trying to clean a piece of copper on a ceramic carrier, and somehow that copper became oxidized and it came out stuck to the ceramic with such a tenacious bond. They thought, well, this is a real happy accident, right? We want to try to take advantage of what we just accidentally discovered here. And so they patented DVC and they figured out how to make it repeatable. And we wanted to get into that. So I'll get into the nuts and bolts here. What we do is we take our copper foil, which makes up the circuitry for your DVC. Okay. We bring in large rolls of this copper. It is a very specific type of copper, a very specific grade of copper, none of which I can tell you. but I can tell you that what we strive for is the highest, most void-free rate of adhesion possible. And in order to make it stick to the ceramic, sticking to the oxide ceramic is one thing, but sticking to aluminum nitride's a kind of different animal. So what you need to do for the aluminum oxide and beryllium oxide is we oxidize that copper. So before, after. And we do that via a chemical process. It's a proprietary blend of dips and rinses until we come out with the proper oxidation weight. Now, if you are trying to bond to aluminum nitride, you will discover that you need to oxidize the surface of the aluminum nitride. That is no easy feat, and it is something that we work on every day here. So what we then do is we take our ceramic. In this case, this could be aluminum oxide or beryllium oxide based on the brilliant white color that you see here. Okay, so we've taken our raw copper cut to size. We've chemically oxidized it. We have our ceramic. We put them together like so, as well as another piece on the bottom. And we run them through one of our belt furnaces at over 1,065 degrees C. At about 1,065 degrees C, this oxide goes molten at the interface between the copper and the ceramic, forming a very strong bond to the tune of about 50 to 60 pounds per square inch of peel strength. So we took that raw copper, remember? We oxidized it. We then put it on our ceramic. Now you have it, stuck on both sides. And there is no way you are peeling this off. I mean, this is on there. So what we then do is we have our blanks, if you will. That's when being a custom manufacturer really starts to lend itself to our expertise, right? Because we can work with a handful of these, we can work with thousands of these. So what we then do is we do the photolithography, where we take dry film, photoresist, and we laminate this DBC blank structure that we've built. And then we laminate it, right? Pattern, develop, expose, until you have your pre-etch DBC structure, right? So we know what we're going to etch. What looks like copper still will etch away. What is blue will remain. It's a subtractive process. Now I don't have this exact one in front of me after etching, but this is what ends up happening, right? We've etched away everywhere where there was an exposed copper color, leaving only the circuitry that you desire. In this case, you'll see we have 9 unique parts, individual parts per substrate. So that would be a 3x3 array on this particular size substrate. What we then do is, depending on your requirements for plating, in some cases, our customers just want raw copper. But more often than not, our customers want a plated structure. So what we'll do is we'll electroless plate nickel and gold if you'd like. We can do a flash of gold. We can do upwards of over 100 microinches if you wanted. Why anybody needs that much gold, I don't know, but we can give it to you. And you can see here, here's a DBC structure that has gone through all the processing that we've gone through and has been plated, nickel and gold. Now, in between all of these operations are various DBC inspection steps. So after plating, or excuse me, after etching, we're looking for voiding. We're looking for mouse bites. Mouse bites are essentially little areas where the etchant may chase laterally down a conductor. So it looks like almost like a mouse hole in a wall, like a cartoon you used to see when you were a kid. And we'll screen those parts out or X them out. Now, after we plate, it's going to go through our QC inspection. They're going to do plating adhesion testing. Right? They want to make sure that that plating is on there. Okay, as well as some other testing that you may require. That's not a problem for us. Solderability, wire bond testing, it's a piece of cake. And what we'll do is we'll send this off to our dicing department, and they'll dice these into individuals. Now, again, this is not this particular part, but it just gives you an idea of how we do it. After that, it goes through mechanical or dimensional inspection, cleaned properly, right? Because a lot of these DBC boards are diced in wax. And the reason for that is so that they're secure, because if you dice on tape, there are chances that you could get some chatter during the dicing operation. And if you get chatter on your substrate, you're going to get cracks and you're going to get chips. We can't risk sending our customers marginal parts. So there's an extra cleaning step in there to make sure, or to ensure that we've removed all of the wax from the substrates themselves. And now we can do this on a large scale like you see here, to individual pieces like you see here. Some of the smallest pieces we do maybe are a couple of millimeters square. Our design guidelines are on our website. You can actually email me or call me and I can guide you to those guidelines. Or I can just send you a copy. Or you can go on our website right now, and if you go to products, DBC, you should see an area where you can download those guidelines. That'll give you everything from the max copper thickness that we can work with. As I've told you, we start out here. More often than not, we're starting out with 300 micron thick copper. Okay. Now, whether chemically or mechanically, we can bring that copper down to as low as 50 microns. One of the new developments we've had here is we've had customers ask us, well, I want thicker copper. I want something, you know, around, I don't know, let's say 500 microns. Well, what we can do is we can actually bond 300 micron copper to the 300 micron copper structure that we've already built to create a much thicker DBC layer. The only thing is, the thicker the DBC is, the larger your spaces and traces have to be, because the etchant not only chases or removes your conductor after your photo process, not only removes it vertically, but it removes it laterally. So we have to compensate for that. We can achieve feature sizes in DBC as small as 150 microns or 6 mils. In the thickest copper we have, which is 300 microns standard, it would be about a 430 micron min feature size. So as you can see, the thicker we get, the bigger the feature size, as well as the etch tolerance that goes with it. But we'll walk you through this whole process. You guys come to us with a DBC design. We're going to chat with myself. We're going to chat with our applications engineer, Brad. We're going to exchange red line drawings so that you understand exactly what it is we can do. And, you know, as you're doing this, right, we're not in this to do one job for you guys. We want to do many jobs. So the more we educate you on what we can and can't do, the better it is, and the more equipped you come the second time with your design, right? A lot more people than you think come to us afterwards, second, third time around, and they've adopted all of our design guidelines in there. And it's fantastic, right? Because it feels like we've, made progress together. So that's basically our DBC process in a nutshell. Some of the more unique things that we're doing right now, as I showed you last week in DBC, not a lot of people can do this. We're doing lead off technology. Now we're not brazing these leads on afterwards. We're not brazing on a lead frame. We're actually etching these leads out of the copper after it's been bonded to the substrate at 1065C. It's a pretty unique process right there. Not a lot of people can do that. Notice that was nickel and gold plated copper on aluminum nitride. You can tell by that gray hue of the ceramic. And here you have direct bond copper nickel plated on aluminum oxide. And some of the more unique parts that we're making with our DBC process is, as you know, we're making coolers. And a microchannel cooler, and you can find out a little more detail on our website in the stellar cooling solutions section, is we're actually taking multiple layers of copper and bonding them together, each layer having a varying etched structure, so that coolant is going to go into that structure and chase through these channels that we've created with the varying etch structures to cool a high-powered chip. Now, this is a cooler in one of its more raw forms. It is yet to be diamond turned. It is yet to be plated. But it gives you an idea if you can see there. I don't know if you can or can't. And actually, what I'll try to do is I'll try to bring up some photos here to show you what some of these coolers look like. That way, let's see. Let's share our screen here. Okay. This is an example of one of the all copper coolers that we manufacture. And you can see, if you're following my mouse, the various layers of copper that go together to make up this structure. And you see the mirror-like finish on top. That's from diamond turning or diamond machining. We diamond machine to make sure that these parts are held to an extremely critical tolerance on thickness. Let's see what else we got. And here is a version of a microchannel cooler, an isolated cooler, using direct bond copper structures as both the top and bottom. You can see here it's aluminum nitride on the top and aluminum nitride on the bottom. You can also see that ALN in there to create that same structure as you saw earlier, but just using direct bond copper instead of all copper, right? So let me go back to the screen here. And open up the chat box and see if anybody's got any questions, any comments. You can type them in, you can unmute yourself and ask away. I know somebody's got a question out there. So one of the things that we also do to ensure that we have the bond strength that you're needing and that we feel comfortable with providing as a quality product at Stellar, what we do is we run bond strength samples with every lot that we put through the furnace. And this would be one of those samples. Okay, and you can see we've removed the copper here. And what we're left with is a nice rosy oxide. That is the copper oxide that is a result of the oxide on the copper after it bonds to the ceramic. It's a eutectic copper oxide bond. So if you got that nice rosy color in there, nice even distribution, that's exactly what we're looking for. Yep. And we can do X-ray, right? So we can quality check the DBC, looking for voids, looking for tents, which have commonly plagued the DBC process since its inception. But everything we do is build to print. We don't offer any standard product. In the future, we may offer some standard off-the-shelf microchannel coolers, but for now, they are custom built per customer. Like I said before, we can do a handful of parts. We can do tens of thousands of parts. Hey, Tom, what's the maximum size? The maximum size part that we can manufacture in DBC would be 5.5 by 7.5 inches, of which the usable area on that structure is about 5 by 7. Let's see, I have some parts here. I'll show you. This is a 5 by 5. I know somebody razzed me last week for getting up, but I'm going to get up anyway so I can show you an example. Here we go. Sorry about that. 5.5 by 7.5. In its raw form after patterning and etching. Any other questions out there? Well, some of the applications where we're seeing Jacob coming to me with a question about where we're seeing interest in these microchannel coolers is anywhere where you're using a high power chip. Now they don't need to be produced on a small scale like this. We can produce them as much larger structures. So in fact, where we're seeing most of our activity is the high power laser diode market, where these chips are just churning out more and more power. You need a way to actively cool these structures. And that's why we got into manufacturing these. And a question coming in from Alexander. How do you assure the flatness of the DBC? There are different specs for different temperature ranges. Well, that's an interesting question. And I can tell you that we never really know the extent of what our customers are doing with these parts. So what we'll guarantee typically is flatness measured under a restrained state. But we can work together with our quality department to define closer to what you want. It's just as a generic note, we always tell them in a restrained state, flatness will be measured. Are any customers using pattern coolers so that they can put multiple chips on top and they're interconnected as needed? You know, I think what they do in some cases with these is they stack them up. And that's Greg. It's throwing me off because it shows up as Sandy, but that's Greg. So they'll stack these pieces up and they'll actually be gasketed to one another so that the coolant is running through several structures at a time. But like I said, we could make them on a much more grand scale. We could make a cooler this big if you wanted it. Now they can have macro channels or micro channels. In this case, the micro channels, you know, are smaller than, let's say, 15 mils. But we can definitely pattern that top surface, you know. So I don't know if you were looking for something that maybe had a depression in there, Greg, or some unique features. You just let us know what you need and we can do it. That's one of the best things about working for this company is that we're not constantly making widgets. Everything we make is unique and different, custom to each one of you. So that makes it exciting, right? When we come in, we're not making, you know, little 1 millimeter squares. You know, it's really, the thrill is gone with those, right? But when we're doing this, which maybe 1 or 2 companies in the world can do, that really is exciting. That's a good question, Tom. Macro channel coolers. That's up to you. What type of channel dimensions you would you'd like to have in there. I know that what we'd want to make sure is that we have an adequate amount of layers to prevent any buckling during the pressurization of these parts, which is part of the testing that we provide when we before we ship to our customer, as we pressure test each and every parts to make sure that they don't leak. But in some cases, you could have a weak point in your structure, and we want to make sure that that's not the case. I have questions coming in on the screen and on my phone. Okay. One of our customers actually puts 12 chips on coolers. So that's totally possible. It depends on your chip size, depends on what it is you need. Depends on what you're cooling. And a small laser diode chip is small. Any other questions out there? I'll stare at you until you ask me one. That's a good question, Alexander. We currently are exploring providing our customers with AMB technology. And if anybody's wondering what AMB is, well, first of all, DBC is direct bond copper, sometimes called DCB, depending. If you're from Europe, a lot of times you call it DCB. US, we call it DBC. AMB is active metal braze, and where the copper structure itself, the foil, is brazed at relatively high temperature to the copper, let's say about 800 degrees C. But you have to put down a conductive layer, seed layer, onto the actual ceramic before you braze it. And once you do your photo pattern and your etch back, you're still left with a conductive layer in the isolations that you formed in your copper. And it takes some pretty nasty chemistry to remove that conductive layer, or it's a mechanical removal of that layer. So we haven't really perfected that yet, but I would hope in the next, I don't know, I'd say 6 to 18 months that we would be able to offer that technology to our customers. And let's see, are the components attached to the coolers die attached? Yes, a die is actually attached to the cooler itself. Sometimes they use an interface. In some cases, they've used little spacers to compensate for the expansion coefficient difference between the chip and the copper itself. So if you're using a chip that's got a thermal expansion of 5 ppm, you know, copper is quite a bit higher than that. You know, you may go with some sort of interface like a copper tungsten submount that's going to help compensate for that 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 difference in expansion. Let's see. How does the what's the advantage of AMB? Well, the advantage of AMB is that it's a little more of a pliable structure, so that at temp cycling or thermal cycling, you're going to see longer performance or better performance. The expansion differential between copper and any of the ceramics that we use, BEO, ALN, alumina, is quite high. And after extensive temp cycling, right, you can see some degradation. With active metal braze, that's not the case. Our website is filled with pictures that you guys can see too. And some of them actually have pictures of the coolers with the die on them. And I'm going to go there right now. Let's see. And wire bonded. So here we are. I'm going to share that screen. And you can see right here on the Stellar Cooling Solutions page, products and technologies, at the bottom, cooling solutions. You'll see that piece there. That's one of our coolers. An insulated cooler, so you can see the ceramic interface. And you can see the, I mean, I can't even tell you how many wire bonds our customers are putting there. But it's a lot. $1,300, I'm told. 1,300 wire bonds in this. And this is the size of the part here. You're looking at it in its raw form, right here. Pretty wild, right? 1,300. It's awesome. It's used for a disc laser pump module. Any other questions out there? How many thermal can these withstand, and at what temperature? It depends on the design. It is solely design dependent. As you can see, in some cases, what we'll do is, I don't know if you can make that out there, but we actually dimple the ceramic, the copper. That helps with its resistance to stress during thermal cycling. But again, customer specifies how many cycles it needs to pass. It is solely design dependent. And by these, Mark, did you mean coolers? Okay, let's see. I might have an expert on the line. How many temp cycles do these go through? Well, the temperature range -25 to 80 C. About how many cycles are you thinking? Gunman is one of our managing directors. So you can probably see, those are his comments there, public. 250 cycles min. Which in this case, the insulated coolers are a DBC top, a DBC bottom, and 6 internal copper layers. That's 8 layers. So that's a lot of moving around. Corrosion tested up to 35,000 hours, and they're still okay. You're welcome, Mark. Any other questions, anybody? as Goodman said, we'll have a special tutorial on coolers only at some point in the near future. We'll probably go through some of our other core technologies first. We'll go through thin film, we'll go through thick film, where we're doing laser diode submounts or photodiode submounts, wraparounds, all that fun stuff. So over the next few months, you'll see some real exciting Stellar tutorials come out. Anybody else have any questions? All right. Well, thank you everybody for attending. That was fun again. And we're going to do it again in a couple of weeks. So look for numerous email blasts from Stellar telling you where and when we're going to have it with an RSVP, so it'll go right into your calendar. Thanks so much for joining us. We really appreciate it. If you have any questions about DBC, no matter how simple you think it may be, there are no stupid questions. Email me, call me. My contact information is on the website. I'll give you my cell phone number is 508-277-0034. This phone is always with me. You guys can call me anytime to talk. And looking forward to working more and more with you guys in the future. So have a great day.
Thank you.